Hello class, welcome to Pre-Algebra Lesson 5.2, which is all about real numbers. By the end of this lesson, you should be able to identify and describe sets of numbers in the real number system. So let's start by looking at what the real number system is. Okay, so this graphic organizer is meant to help you organize numbers. So something to look at is, let's start in the very center here where we have natural numbers. So natural numbers are like the numbers that if I were to ask you to start counting, what would you say? Most of you would say 1, 2, 3, 4, 5, 6, and you'd keep going until I told you to stop or until you got sick of counting. So natural numbers, like kind of like the numbers you use to count when you're playing hide and seek or something like that. So those are like the counting numbers. So like 1's an example, 100 is an example, 2,000 is an example. So natural numbers are those kind of like really nice numbers to work with. Now, whole numbers include all of the natural numbers. So whole numbers are also 1, 2, 3, 4, 5, and so on, 100, 2,000. Those are all whole numbers. But whole numbers also includes the number 0. Okay, so natural numbers does not include the number 0, but whole numbers includes the number 0 and all of the natural numbers. Okay, and then let's get a little bit bigger. Okay, let's talk about what is an integer. So an integer is all of those natural numbers. It's the whole numbers, so the number 0, and it's also our negative numbers. So like -1, -2, -1,000, -50, -35, -7. Okay, those are all examples of integers, but integers also include 0 and all of the positive versions of these negative numbers. Okay, then rational numbers are all of those numbers that can be written as a fraction, so like 1/2, or as a decimal, 0.5. But when it comes to a decimal, it has to be a decimal that stops, like 0.5, or a decimal that repeats, like 0.12 repeating. If it doesn't stop and it doesn't repeat, that's where we get something called an irrational number. So if we were to have something that was just random like this and it kept going on and it doesn't have any repeating, that's called an irrational number. A really common one that you guys are used to is the number pi. So it's that 3.141592653, and it keeps going, right? It doesn't repeat, it doesn't end. So those are two examples of irrational numbers. Some other examples of irrational numbers include, like, if you were to type in the square root of 2, that would give you a decimal that doesn't repeat and doesn't stop. And same with like square root of 3, square root of 5, and so on and so forth. Okay, so an irrational number, though, stands all on its own. An irrational number can never be a natural, whole, integer, or rational. So if it's irrational, it cannot be anything over here on the left-hand side. Okay, so let's do another quick recap. So natural numbers are like the counting numbers. Whole numbers are all of our natural numbers plus the number 0. Integers are all of our whole and natural numbers plus the negative versions of the whole and natural numbers. And then rational numbers are all of those decimals in between, well, not all, but it's like decimals in between that are repeating or ending, or the numbers that are fractions, like 1/7 or 7/9, -7/9, -2/3. Those are all examples of rational numbers. Okay, so we're going to practice classifying our rational numbers. So let's look at this very first example. We want to identify what real numbers. So let's determine whether -25 is rational or irrational. So first we'd say, can -25 be expressed as a ratio in the form a/b? So what that means is, can it be written as a fraction? And really, -25 can be written as -25 over 1, right? Because if you do 25 divided by 1, it would still just equal negative 25. So yes, it can be expressed as a ratio in that form, okay? So when it's in that form, we have negative 25 over 1. Are A and B integers? So remember, integers are positive or negative numbers that aren't decimals. So negative 25, that's an integer. 1, that's also an integer. So yes, both of them are integers, and B, the number on the bottom, isn't 0. So perfect. Then we have a rational number is a number that can be expressed as the ratio of two integers. So if we keep going off of that, we know that since negative 25 can be written as negative 25 over 1, we can say negative 25 is a rational number. So I would say negative 25 is rational. Okay? So I want you to look at this one and say, determine whether negative 2/9 is rational or irrational. Good luck. Hopefully you figured that this number, negative 2/9, is in fact a rational number because it is written as a fraction, and it has a negative. That's okay. A rational number can be negative. So this is a rational number. All right, now let's look at example 2, where we want to classify real numbers. So we want to name all of the sets of numbers to which the real number 0.2525 belongs. So remember, our options are natural, whole, integer, rational, and irrational. So let's go through that. I'm going to change my pen color quick. Okay, so natural numbers are like the counting numbers. Would you start counting by saying 0.25 repeating? No. So it's not natural. And whole numbers, also, they don't include decimals either, so it's not a whole number. Integers don't include decimals, so it's not an integer. And then I want to figure out, is this rational or irrational? Well, I see that the 2.5 is repeating. So since it's a repeating decimal, this is a rational number. And if it's rational, it cannot be irrational. So this one only belongs to the real number set, rational numbers. What if I give you the number like, let's say negative 5? That would not be a natural number because natural numbers don't have negatives. It's not a whole number because whole numbers don't have negatives, but it would be an integer, and it would also be rational. It would not be irrational. So in your assignment, on the review, on the test, you're going to be given like lists like these, and you're going to have to be able to say, okay, it's not this one, not this one, but it is this one, it is this one. And it's possible for them to be all 4. So what if I had like the number, let's say I had the number 3. That's natural. That's one of our counting numbers. It's also a whole number. It doesn't have a decimal, and it's positive. It's an integer because it's a number that doesn't have a decimal, and it's a positive, and then it's also rational. Okay, so hopefully that helps you. And then since it's rational, it can't be irrational. All right, I want you to figure out, name all the sets of numbers to which the real number 21 over the square root of 4 belongs. Good luck. All right, for this problem, hopefully you figured out, okay, 21 over the square root of 4, well, the square root of 4 is 2. So I'm going to say 21 over 2 instead. And 21 over 2 is not a natural number because that's not something we would count. It's not a whole number because it's not 0 or a number we would count. It's not an integer because it would have a decimal, but it is rational because the decimal would end, and it can be written as a fraction. So this is a rational number. This is not irrational. All right. Now let's name all the sets of numbers which the real number, the square root of 36, belongs. So in order to know, in order to know, I have to actually figure out what is the square root of 36. That's 6. Okay, so now I'm going to go based on this number and say, okay, is 6 a rational number? Yes, it's rational. Is it an integer? Yeah, it's a number that doesn't have a decimal. Is it a whole number? Yes, because it is a counting number. And it is a natural number because, again, it's a counting number. However, since it's rational, it cannot be irrational. All right. Now I want you to try and name all the sets of numbers which the real number, the negative square root of 64, belongs. Good luck. All right, hopefully you determined that -8 is rational. It is an integer, but it is not a whole number, natural number, and it's not irrational. If you have questions about that, please be sure to ask for some help. All right, let's try another one. Name all the sets of numbers which the real number, the square root, or the negative square root of 7 belongs. So I want to figure out what is the square root of 7. And there's a negative, so 2.645751311. Okay, so these are not repeating. They are not ending. They're going on forever and ever. So this is an irrational number. So I would circle irrational, which means it cannot be any of these 4 other things. Okay? So if it's irrational, it automatically means that it cannot be an integer, whole number, or natural number. All right, now I want you to look at name all the sets of numbers which the real number pi belongs. Good luck. Okay, so hopefully you remember me talking about how pi is an irrational number. If you don't remember that, that's okay. Maybe you looked at it and you said, okay, what's pi? Well, it's 3.141592653, and it keeps going. Those numbers aren't repeating. It's going on forever and ever. Therefore, it has to be irrational. Okay, and that is the last example I have for you today. I recommend definitely keep this handy. I recommend maybe copying that kind of graph or something like it down on a note card so that way when you take your test, you don't have to try to remember all of this, okay? You have this nice graph to help you read and classify numbers. If you have any questions at all, please be sure to ask for some help. I'm happy to help you. Have a great day.